Hello, welcome to the third lecture in this row here. This time about innovation management. Maybe a bit strange that this lecture is in the middle of this row, the series of lectures, because some topics before social network analytics and human resources have to do with innovation management, and many topics after. But I thought in the middle would be exactly the right, so that you see that all is somehow interrelated, interconnected. So innovation management is a broad term, and human mankind did produce innovation for thousands of years. It's not anything new I'm talking about. When we go 4,000 years back, 2,000 years before Christ, the Egyptians were building pyramids. It's of course a kind of innovation doing so. I mean, you have to, let's say, draft them, concept them, build them. It's a lot of management involved, a lot of people involved that have to be organized. The material has to be organized. The thing has to be designed. And same as the Chinese Wall, 2,000 years later. The thing has to be designed, built, organized, workers have to be around. So there are many things of management issues that have been solved for thousands of years. I mean, the third picture here shows the ISS, that's rather new. Altor, it will be, I think, substituted in a couple of years. It's already in space for around 20 years. What history showed that after agricultural push or revolution in the 18th century, in the 19th, 20th century, the amount of innovations, inventions and things on the market, industrial products, enormously were rising. And since 200 years we are inventing, innovating more and more and accelerate that in an exponential speed. I mean, many products appeared in the last 200 years or even less than 200 years. So all this product here, it's probably the bike, which at this shape displayed was invented from a British researcher end of the 19th century. All other products from the last century. The last one probably the mobile phone. All that products shape our daily life. So they of course look different. A television looks not like a television at this picture anymore, but all the things came into life the last 200 years. And if you consider that human mankind is on this planet for already maybe 100,000, 200,000 years, what all happened the last 200 years is tremendous. But also when we look at our energy consumption, energy production, a lot of things happened. Of course, water mills and windmills were there already for centuries. So we were using water energy, water power for already hundreds of years. The same with wind power. Everyone knows this wind and water mills that are still there, and you can visit them. What's rather new from the last century is solar arrays. It's around 100 years old, this technology, or the first attempts of this technology, and tight power energy which are used now. That's technology actually to come back to replace all the fossil energy we are using, we are overusing and polluting our planet nowadays. But that all has to do with innovations. That are innovations. You innovate to make actually something better for someone. It has not to be necessarily sustainable. We haven't been very sustainable, to be honest, the last 200 years. You could actually say, oh, the entire speed of innovating, accelerating that, bringing new products, processes on the market has actually brought us in a situation now where the environment is polluted so much that we are in danger as human mankind, and we have to reconsider that. On the other hand, of course, we can go back in living standards, we can go back in wealth, but still we will have to replace the use of fossil energy and many things we do with new technology. So we actually cannot stop innovating. That would be the wrong way. maybe we can bring down the speed of innovating to be more reflective, more sustainable, to have more ethical issues solved during product and process innovation. That might be true, but we cannot go away from innovating. And the last 200 years are actually also seen as a new period of innovation, because it really is distinguishable from innovating in the past. Innovating in the past was a reaction coming from religious beliefs, from attacks from other cultures, from other human beings, from other tribes, from being hungry, from a lot of things that were actually on our shoulders and burden us, and we try to solve this, to have enough food, to have a safe life. And that was actually reacting to life conditions and circumstances at a certain time, like the Egyptian pyramids, like the Chinese wall, like many things that happened, buildings, farming in the last centuries. But what we do in the last 200 years is a purposeful search for innovations to actually bring them on the market, and have consumers buying it, have other groups of people using that. And this purposeful attempt goes back in the literature to one man, that's Edison. And Edison is an inventor and has his labs and has entire teams trying to invent new things. That was the purpose of his innovation labs, to purposefully and in an organized and coordinated way create new innovations for B2B, business to business, or for customers. Some of his innovations are displayed here. The light bulb, everyone knows. Another one, the kinescope, was actually the origin of the technology we were using in cinemas later on. So there were many, many inventions that actually has a huge impact on our life and future technologies. There's other literature saying, okay, Edison is an example, but there are other examples, and one example is also the chemical industry in Germany, which was quite inventive in the 19th century and also applied methods of purposefully searching for innovations. When you take innovation management, it has actually three sides. I mean, it has a market. Innovation can be distinguished from an invention by having someone using it, paying money for it, having a market for it. An invention is just something new. Nobody uses it yet. So markets actually are part of innovation management. Since management became an academic discipline propelled by Herbert Simon in the 60s, who got a Nobel Prize, and is seen as a kind of godfather of business administration. The first professorships and academic projects and universities engaging in that were actually coupling marketing and innovation. So the first professorships in this field were professorships in marketing and innovation management. Later on, it developed as its own discipline. It was getting more specialized with technology management. And it was also coming together with entrepreneurship that also developed in 70s, 80s, 90s. So that isn't any different. Product development is more closer also to engineering design, as we will learn in this lecture, but also part of organizational design, because you develop products in an organization. So organizational development, which goes more in the direction of social science. So innovation management is a quite broad discipline, also covering a lot of smaller disciplines in business administration. As you look here, I mean, human resource management certainly is part of innovation management in a certain field. Social networks are inherently part of management questions. Of course, creativity, as inventions and innovations are a result of creative efforts. Mostly you have more than one guy working on an innovation, so you have a group, and entire project, so you need a kind of project management. You have some market with customer demands and wishes, with users innovating, and you have the systematic design methods which actually are embedded in project management. And of course that all comes also back in simplified versions of business plans or canvas business models as you use it in other modules. So the business model actually has to combine that all. What we do here in innovation management, I want to direct this lecture more or less to three facets, because we do all other aspects, we discuss all other aspects in other lectures. We will discuss here about the systematic design methods, about the project management part of innovation management, and about creativity. We still have a lecture on user innovation, and we still will talk about all aspects, or we have already talked about those aspects as about social networks and human resource management. If we go into systematic design methods, actually 4 methods or principles are central. That's the principle of hierarchical decomposition, it's the principle of systematic variation, it's the principle of satisficing, and the principle of discursiveness. The methods were developed over centuries, but actually in the last century. I mean, Leonardo da Vinci at this time was already working systematically on innovation, and were actually using these methods without naming these methods like that. But actually during the First and Second World Wars there was a huge push on developing methods to be faster in product development. Of course we speak about military products, and it's the First and Second World War, and it's not so surprising that these 2 authors, Erkens and Kesseling, are 2 Germans actually publishing about systemizing the methods in engineering to be faster and more effective in a higher quality in this sense, in producing new technological products. Mostly we speak about military products. Later on, Herbert Simon, more from a philosophical point of view, were taking over that and researching, discussing that. Later, Paul and Beitz wrote an important textbook about that. Beitz, by the way, was professor here at TU Berlin. Later on, Diamond, Little and Cross, very readable books about systematic design literature in engineering. What does it actually mean? If we speak about hierarchical decomposition and we take a product like an electric scooter here, looks like futuristic, looks nice, a lot of new parts, new design, but what does it mean how to do that? When you start actually developing such a concept, you of course start to decompose the product. You put it into smaller parts. You have the entire scooter, then you have the basic framework, the functional accessories, whatever you take, you can put it in main parts, components, subcomponents. So you actually break down hierarchically the product in subcomponents. And the subcomponents have some interfaces, direct relations, strong interfaces, indirect relations, weaker relations. The same as I have shown with the satellites, where we will come to at the last lecture about social networks. It's nothing else than a social network. Every product can be broken down into a social network. It's the same maybe with the shaver here. There you see the main components with the protection cap, shaving unit, driving unit, cover assay, power supply, housing. That are examples from last lecture, breaking down a satellite into solar arrays, battery, and so on. But you also can do it with the entire airplane. I mean, if you take this airplanes developed in Europe, that can be broken down in main parts, and that are even developed at different countries, the main part. And it would look like that. It's a design structure matrix with a modular system and main parts and smaller parts and strong and weak interfaces, as shown with this electric scooter. Nothing different. That's where you start. You take the product you want to develop, break it down, and assign people behind it. It's also the first part of managing the project in getting a structure done, and the structure actually has its core on the product structure itself. Then you have structured that. Okay, what do you do? And that's a good example from Leonardo da Vinci. That's drawing a baptism of Christ. And what he did, when you see this hand over his head, he was wearing this hat. So X-rays shows that he was actually wearing this hat many, many times and drawing it many, many times before he decided that's the best solution. And in this way, he took this functional part of this drawing and was wearing this part many, many times to get that done. And that's actually also what we do with creativity. We try to find a creative solution to a problem. And that was a small part of this problem in his drawing. And for creativity, we developed a lot of different techniques. The oldest one, developed by Osborne in the 50s of the last century, brainstorming. I mean, you all and many people still speak about brainstorming. That means, as Osborne describes it, 12 people are sitting in a room and exchange ideas, problem solutions without criticism and without judgment of ideas. So it's an open, non-negative discussion and exchange of information and ideas. However, research tells us, and there's many research, there were some 300 research articles showing in experimental settings, in empirical tests, this model doesn't work. The same amount of people alone in a room produces more and better ideas. There are several reasons for that, because humans are restricted somehow, and humans cannot listen and think at the same time with the same efficiency. And being in such a group means to listen and to think. And so the amount and quality of ideas expressed by humans will be less than being alone. The second thing is that you have a social structure. You have dominating people there. You have people actually driving his opinion into this group. You have free laughing, that people say, okay, that's a group, I don't do anything and we will have a group result, should I make an effort? So there are many, many reasons why this group don't work. There are solutions for that, by having someone really going into the group and moderating this process, by going out and in, working alone, working in a group. So there are solutions for brainstorming, but the classical brainstorming has proven to be not workable for creativity. It is working when you want to get something accepted in a group. Then brainstorming is working, but not for getting the best idea. Nowadays you have other techniques in creativity to use. Design thinking is something which is used at this time quite often, developed at Stanford and used here at this university or at many other universities. You have TRIZ, most of you want to know TRIZ, developed by Altschuler already in the 60s, 70s. It's a Russian technique. You might label it the Russian design thinking. It's more engineering-like. It orientates itself more on engineering methods, but it's also a very successful creativity method. You have bionic orientating when you get creative at nature, at skin's appearance, behaviors, movements, what you ever find in nature materials. A good example is an iCat. You have when you are biking or running or whatever you do, that people can see you when it is dark. I mean, it really goes back to cats. When you're driving a road and a cat is next to the road, you see these eyes very clearly when it is dark and your light goes into these eyes. So they reflect light, and researchers found that out, that there's an illuminating substance in the eyes, and when you use it, you actually can use it for iCats. So it actually is a kind of bionic in copying what nature actually invented for us 1,000 years ago. You have mind map. You all know that by drawing your things. You have storyboard, doing it with papers. So there are many techniques that propel creative results and that are used also in all engineering projects and all innovation projects. It's necessary at a stage after you have broken down the product into components and subcomponents to get the most creative ideas. And that's mostly done in a kind of morphological chart. We have this what's labeled here as function is actually as a component or subcomponent, and then you look for solutions. Like you have it here, a share component. Okay, you have the seats, the back, the armrest, the stand, and you can actually vary. It's therefore systematic variation. And then you can assemble that as a new kind of share. And that's what is done in engineering. Subcomponents, solutions, putting it together. Still, there are some interfaces you have to consider. If we take this physical, that's the tool where you actually move with your own body power, with physical strength. And there are solutions. You have this human power, you have steering, transition, surprise, learning effect, whatever. And you also can model that to a best solution. I don't know what will come out here. It's just showing you a morphological chart, putting the solution, using creativity on the component level. Okay, somehow in an innovation project and in innovation management, you have to put all things together. So that's the innovation funnel. You come with a lot of ideas, you have broken down everything, you have big morphological charts, but at a certain point of time you have to find the best solution, go through it and integrate all. And then you have to put it on a market and put a lot of effort of really getting the innovation done. And that's actually done in stage gate models. So that you have the first stage, first concept ideas. Then it is evaluated. Do we go on or not do we go on? And then you have the next stage, feasibility tests, product tests. Does it really work? Then again a decision, do we go on, put money and people on it or not? So it happens in stages because it's dangerous, expensive for companies to invest in something which does not work out. Of course, not any innovation project works out, most don't. Still, you can stop it at the stage where it doesn't work anymore, where investment would not be to justify for a management. And therefore, you have the stage gate procedures in product development, which are part of innovation management, and setting the skates, evaluating and going on with the skates. I mean, just taking an example, if you are a big producer in automotive, you now have a choice going and putting a lot of money in going electric in your batteries or going in hydrogen and putting money in developing entire new cars, because the change with hydrogen is much bigger than with electric cars. But you don't have the money your own and the competence your own in going in both directions at the same way. So what you see now that certain automotive companies try to go in both or go one in more direction, the other goes in another direction. It's a kind of what we will see and what markets will show what will happen in the next 10 to 20 years. Whether electric power will stay or hydrogen will come or a car might not be so important anymore. But still, innovating is extremely expensive. And you have to use partners. You really have to look for your own competences. What really can I do my own? Where do I find partners doing that? And what really makes sense for my markets and my also organizational capabilities to do so. Next thing is organization. Yeah, a classical organization is functional, like our university. We have a finance department, research department, whatever. So it's actually very functional, organized. The thing is, if you do a project like developing a new hydrogen engine, it's difficult because you might need a lot of people in there. You might need people from a legal department looking at some things. You might need people from a business economy department. Of course, you need the engineers. So you actually need a project next to that as metrics or whatever. And mostly nowadays, it happens that this project is actually next to, so that the staff, the engineers, the scientists, the experts are delivered to the projects and spend time in an organized project next to the organization, in a project organization, maybe even in a kind of network organization, because most of the larger companies work in a multi-project environment. You don't have only one project, you normally have hundreds of projects at the same time. And of course, coming back to the design structure matrix, within this project you try to structure it according to the product breakdown structure. There, the combination with engineering design methods, and that appears as network. And you use a lot of project management techniques. I'm not going too deep into that. One of the major ones is a Gantt chart, showing you a timetable and a time plan, which has to be in mind all the time, because time is a deciding factor. Just an example from developing space technology, the constellation of stars in space, of planets in space, is so that you have only certain time slots for launching satellites. So in this way, being too late might cost you 2 or 3 years, and it's enormously expensive. And there are many other projects where time delays are enormously expensive. So a Gantt chart actually is the best method of observing that. But it's only a very shallow or easy, simplified method of real current project management. It's the same as an activity network, where you can see where you have slack free time or free capacities to put on other projects in a multiple project environment. And for 10, 20, 30 years we speak about agile project management, working in iterations, learning, putting it into that, giving feedback. It's quite similar actually, this agile project management to lean entrepreneurship, which works somehow on the same principles, and not like a waterfall or a step downwards like classical projects. So there are approaches actually to improve this project management step by step, and we are quite good in that. The question nowadays I would put behind it is, should we really stop focusing too much on efficiency, time to market, being fast, and more on quality by having aspects of sustainability and ethical issues into that? Another one that developed is, of course, we want to actually predict the success. And there are models, and one of the famous models is Newport, developed by Cooper in the 80s, I think, yeah, in the 80s, with a couple of questions, 84 questions on 8 factors, product superiority, uniqueness, and so on. We actually can predict quite precise whether a product we develop will be a commercial success or not. But this prediction has only accuracy of 70%, maybe less. So it's a lot of uncertainty still stays. So it's not for sure that it actually will be a success later on the market, but it at least gives you some stability, security in a management decision, in innovation management. And of course it all comes back in business models, because the business model around all, you have a new product, but this business model has to deliver value to customers. You have to figure out that before and put it in a product. It has to be producible in your own organization. There has to be a market. Someone should be interested in that, having that. That all comes back in your business model. So innovation management might develop business models for something and also deliver at the same time a product. So that's not a big distinction between having a classical business models, where the same ingredients are in there. The customer, the resources you have, the organization of these resources you have, the networks you have to consider, the product itself, the requirements on the product. So everything comes back. And therefore it is no surprise that research actually shows that business models are invented in many kinds. What you probably know in your discipline is a canvas business model from Osterwalder. That's a very oversimplified business model in business administration. There are many, many more business models that are used in practice. That's from a PhD thesis we had here at TU Berlin, and you see, just take the defined definition provided articles which actually have a clear definition of a business model, and you see it comes from many, many disciplines, computer, environmental, economics. So this business models slightly differ according to disciplines and differ in depth. how deep people go into what a business model means, mostly more than what you see at Canvas, because a business model has many more facets. What I actually want you to keep in mind, innovation management is a rather broad, interrelated to marketing, entrepreneurship, to other disciplines. And what's important, you have to learn and to know that engineers work with systematic design methods, and that's part of a work when you start up a company or you work in a bigger company. Innovation is organized by management and underlined by systematic design methods. Therefore, I would like you to read this article.